Welcome to Engage Math, Lesson 27, Problem 3. And we are looking at quadratic functions, this time in particular in the form that's often known as vertex form. The reason it's called vertex form is that we can look at this function and right away tell what the vertex is. So what we are doing is we're really using the opposite of the number that's with the x in the parentheses. That's the x coordinate. And then this number right here is the y coordinate. And that is all based on what's written at the top here. And not only is it written at the top there, but it's also on the reference sheet in the inside back cover of your Algebra 1 Engage Math workbook. So the vertex in this case would be a positive 4, negative 8. So let's plot that, because then that will help us to see where the axis of symmetry would be. Okay, so we're at right here at 4, negative 8. Now the axis of symmetry is the line, and it really is, it is just what it sounds like. It is the line that goes through the parabola right down the middle, making two symmetric portions of the parabola. So the axis of symmetry in this case is the line x equals 4. And it's always for our parabolas that you're working with right now will always either open up or down, and the axis of symmetry will always be a vertical line that divides it into two equal parts. Okay, the y-intercept. So we know that if we want a y-intercept, here's our y-axis, we must have an x-coordinate of 0. So we're going to take our equation and we're going to put 0 in for x and figure out what y is. In this case, we're going to get y equals, we have negative 4 squared, so it's 16 minus 8 gives us a positive 8 for our y-intercept. So I'm going to go and graph that right there. I now have 2 points that I know are on my parabola, and I know that that first one was the vertex. So just like that, I can see this half of my parabola. And again, it's a sketch. We're not watching the exact points. And now, as I try to do the other part, the other half, I know I'm symmetric about that x-axis, or sorry, not the x-axis, the axis of symmetry. So since the point that's the y-intercept is 4 to the left of the axis of symmetry, I'm going to simply count 4 to the right. So 1, 2, 3, 4 puts me right here, and that would be the other point that is symmetric to the y-intercept, but across that axis of symmetry. And the coordinates of that are going to be 8, and then the y coordinate would also be 8, because we are 8 to the right and 8 up to get that other point. All right, you have just graphed a quadratic function from vertex form. See you next time at Engage Math.